The average age of a college freshman is 19 years old with a standard deviation of 0.4 years. Assuming a normal distribution, what is the probability that a given freshman will be between the ages of 18 and 20? So since this is a problem involving standard deviation and normal distribution, the first thing you should do is draw your normal curve and label mu. So as you can see, I have my line down the middle, labeling my mu, my mean as 19. And the problem wants to know what's the probability that the given freshman will be between 18 and 20. So I'm going to go ahead. I don't really care exactly where I draw them. I just want to make sure that 18 is on one side of my graph and 20 is on the other side of my mu. So the problem, if we want to know probability, is actually looking for the area in this region. So here's what we need to do. If we want to find the area, we can't just guess at it. We actually need to find the z-scores for 18 as well as the z-score for 20. So here is the formula that we need for z. Z is x minus mu over sigma, where x is the number we're talking about, mu is the mean, and sigma is the standard deviation. So the first one we need to find is the z-score of 18, and I'm going to write it this way. So the z-score of 18 looks like 18 minus 19 over 0.4, which gives me negative 1 over 0.4, which is equal to negative 2.5. Perfect. That's my first z-score. Next, I'm going to go ahead and I'm going to find the z-score of 20. So the z-score of 20 is 20 minus 19 over 0.4, which is just 1 over 0.4, which is a positive 2.5. So I have two z-scores so far, one for 18, one for 20. Now I'm not done. What I need to do next is turn to my chart, the chart that gives you all of the different areas under a normal curve, and I need to look up what the areas are that correspond to negative 2.5 and positive 2.5. Now remember, any statistics book is going to have the chart in the back of it. Any test you have is going to be, you'll be given the chart on your test. This chart is not something that you're expected to memorize or possibly know. So let's go ahead, let's look up positive 2.5 and negative 2.5 on our chart. So from my chart, I found that the area for the z-score negative 2.5 is 0.0062, and the area for the z-score 2.5 is 0.9938. What does that mean? That means that if we're looking at the area from 0 to 18, that's going to be the area 0.0062. And if we're looking at the area from 0 to 20, that's going to be the area 0.9938. Now, obviously, my curve shaded here doesn't do a proper job, really, of reflecting the numbers that we're talking about. If I were to sketch it, perhaps it would be more accurate, sort of, to sketch it this way, with very little left on both sides. But that's not really the point. The point is if we know this area here, and we know the entire area, how do we find the blue shaded area? Well, all you need to do is subtract from the full area of 20, the smaller area of 18, and once you do that, you'll be left with the area that you want. So we have 0.9938 minus 0.0062, which is equal to 0.9876. So what does that mean? That means in between 18 and 20, 98.76% of the area of this graph is shaded in. So let's go back to the question. It says, what is the probability that a given freshman will be between the ages of 18 and 20? And the answer is exactly 98.76%, because the probability corresponds directly to the area under the curve that we have found.